Okay, in section 2.4, we talk about measure of numerical measure of variability. We use, oh, I'm sorry, so this is not what I'm sharing here. Okay. So in 2.4, we talk about a numerical measure of variability. We use a range, standard deviation, variance to find the variability. Okay, in 2.3, we had a measure of central tendency. We use median, mean, and mode to find the central tendency. Okay. Now, so whenever we have a two sample, we can use this measure of variability. Okay, we can use measure of variability to describe a data set if we have a two different data set. Okay, so if we have a data set with a more standard deviation, it means more spread, more variable, right? So if we have a data set with a less variance, it means less variable, less spread. Now, in our new section 2.5, we will try to use this measure of variability to describe one data set. For example, you have a data set, okay? You have a single data set and its standard deviation is 1.4. Now, is that enough? Is that information enough to describe the variability? So you have one data set, okay, and the standard deviation of that data set is 1.4. Now, do we have, okay, now we don't have other data set to make a comparison, okay? So having an idea of standard deviation for a single data set, that is not enough to describe whether our measurements are more spread or less spread. If we have a two data set, we can make a comparison, okay? So like for example, let's say we have a sample 1, it has a standard deviation 1.4. We have a sample 2, the standard deviation is 0.5. Now, in this case, so we have two samples, so we can make a comparison here, okay? Out of these two samples, our sample 2, okay, so this is our sample 2. Sample 2 has a small standard deviation, it means less spread, okay? But if we are given only one sample and we are given the standard deviation 1.4, then it may not be enough, this information may not be enough for us to describe about sample 1, okay? And this is what we are going to learn in this section. So in section 2.5, we will use mean and a standard deviation to describe a single data set, okay? And for this, we will count the number of measurement within one standard deviation of mean. So this is not if, this is of, okay? So one standard deviation of mean. Now, what does it mean? So let's say we have a number line here, and in this number line, for example, our mean is somewhere here. So let me call it x bar, okay? And we have a standard deviation. I will use s, okay? I have a x bar. So x bar is the mean of a sample, and s is the standard deviation of a sample. Now, one standard deviation of mean means, now here we will count the number of measurement from our mean, okay? So we'll count the number of measurement that belongs to from our mean to one standard deviation to the right, okay? And one standard deviation to the left. So this distance is s, okay? Like, so here, so this distance is s, and this distance is s. So we have our mean x bar, okay? And we are trying to count, we are trying to find the number of measurement, okay? Measurement in one standard deviation to the right and one standard deviation to the left. Now, if this is x bar, okay, how do we, what will be this value? Can anyone tell me what will be these values? So okay, this is x bar, okay, this is x bar. and this distance is s. Okay, s is the standard deviation of sample, and this is also same distance s. Now, how do we find these numbers here? Yes. So let me take a specific example. It will be clear for you. For example, so we have here 4. Okay, and we are given this distance as a 2 and this distance as a 2. Now, how do we find this value? So what is this value equals to? 4 minus 2, 2, right? And what is this distance? 4 plus 2, 6, right? So using similar concept, so here, so this is our x bar minus s. Okay, so this is our x bar minus s, and this is our x bar plus, sorry, this is s, x bar plus s. Okay, and this interval from here, from x bar minus s to x bar plus s, we call this one standard deviation of mean. Okay, so one standard deviation of mean, it is always an interval. Okay, and the interval is x bar minus s to x bar plus s. So this is one standard deviation of a mean. Now here we will learn to count the number of measurement in this interval. Okay, in the similar way, we will also find the number of measurement in 2 standard deviation of a mean. Now 2 standard deviation of a mean means, so we have a mean here, x bar. Okay, so 2 standard deviation means we go 2 standard deviation on the right. So our s is the standard deviation. So 2 standard deviation means 2s. So we go 2s to the right, okay, and we go 2s to the left. Now what is this point? What is the value of this point? This is x bar minus 2s, and this is x bar plus 2s. And this interval, okay, so these are the numbers. Okay, x bar is a number, s is a number, and x bar minus 2s is also a number. Okay, so from this number to x bar plus 2s is the 2 standard deviation of mean. So this is an interval x bar minus 2s to x bar plus 2s. So if you are asked to 2 standard deviation of mean, then this is 2 standard deviation of a mean. Now can you write 3 standard deviation of mean in the similar way? So what will be 3 standard deviation of a mean? It is x bar minus 3s. Okay, 3s to x bar plus 3s. So this is 3 standard deviation of a mean. Okay, so here we will have a one sample. Okay, we'll have a one data set. Okay, and we will count the number of measurement within 1 standard deviation of a mean, within 2 standard deviation of a mean, within 3 standard deviation of mean. Okay, we are describing a single data set using mean and standard deviation. Okay. Okay, now in order to describe the data set, we have 2 different rules. Okay, so we have first rule. Okay, we also call this first rule as a Chebyshev rule. Okay, so here, okay, this is CHEBYSHEBS. Okay, Chebyshev's rule. Okay, rule 1, and we have rule 2, which we call empirical rule. So these are the 2 rules that we will use to describe our data set. Okay, Chebyshev rule and empirical rule. Now this, okay, now before we start this one, does anyone have any question with this 1 standard deviation of a mean, 2 standard deviation of a mean, 3 standard deviation of mean? Now in the similar way, so what would be 2 standard deviation of a median? Who can just write an interval for 2 standard deviation of median? How do we write that interval? 2 standard deviation of median. what will be the interval? M minus 2s to m plus 2s. Okay, so this is the two standard deviation of a mean. Now we are using mean here in this section, but in upcoming section we might use a median. Okay, so if we are talking about two standard deviation of a median, then it is median m minus 2s to m plus 2s. Okay, and one standard deviation of a median is m plus, sorry, on the left side is sub difference m minus s to m plus s. Okay, so you will be asked, so you will be given a data set and you will be asked to find the number of measurement within one standard deviation of a mean. Okay, you should be able to write this statement in an interval form. Okay, once you have this interval form, the remaining is you substitute x bar, you substitute s, and you will get the interval. Okay, so you should be able to write this interval. Okay, now, so the very first rule here is a Chebyshev's rule. Okay, and we can use this rule for any type of data set. Okay, so it does not need to be a data set that has median and mean equals to each other. Okay, so we can use Chebyshev rule for any data set. Okay, any type of data set. But here, empirical rule, we use this rule if our data set is symmetric data set. Okay, we use our empirical rule if we have a symmetric data set. Okay, and symmetric data set means the data set has mean and median equals to each other. Okay, symmetric data set means x bar and m are equals to each other. So if we have a symmetric data set, we will use empirical rule. Okay, and if our data set is not symmetric, then we can always use Chebyshev rule. Okay, this is the difference here. And the next way of saying symmetric data set is, so whenever we draw a histogram of a symmetric data set, we always get a mound-shaped histogram. Okay, mound-shaped means bell-shaped. So we'll see this bell-shaped histogram a lot. Okay, we'll use a bell curve that looks like a bell. Okay, so this is a symmetric data set. So if you have a histogram that looks like a bell shape or a mound shape, it is symmetric. Okay, and we will be dealing with this bell-shaped or a symmetric data set a lot. Okay, you will see this bell-shaped curve a lot. Okay, now let's go to the rule here. So according to Chebyshev rule, okay, now it is possible that very few of the measurement will fall within one standard deviation of the mean. So what it tells us here is that, so there is a possibility that very small number of measurement can be found within one standard deviation of a mean. Okay, so one standard deviation of a mean, this is the one standard deviation of a mean. Okay, this is an interval. Okay, so we find very few measurement. There is a possibility that few measurement can be found within this interval. Okay, now, so what about this interval here? So what differences do we have in between these two intervals? Who can tell me here? So we have this interval and we have this interval. What differences do you see here? That's right. Okay, so the first interval here, we have x bar and s. Okay, so it means this interval is for a sample. So if you are finding the number of measurement within one standard deviation of a sample, then you're going to use this interval. Okay, and we use mu minus sigma. Mu is a mean, sigma is a standard deviation. We use this interval if we are looking for the number of measurement for a population. Okay, but the way we write one standard deviation of a mean for both cases is same. Okay, the only symbol is different here. Okay, so we always find a few number of measurement within one standard deviation of a mean. Okay, the next rule here is, okay, I think let's do an example for this one. So here, so we have this example here. Let's find or let's count the number of measurement within one standard deviation of a mean. Okay. So does it tell? Okay, now it does not tell us our data set is symmetric. Okay, so we have 30 students in experimental psychology class use various techniques to train a rat to move through a maze. At the end of the course, each student's rat is timed as it negotiates the maze. The results in minutes are listed in table. Determine the fraction of 30 measurements in the intervals. Okay, now it does not tell us whether this is symmetric or not. Okay, now let's find or let's calculate the number of measurement within one standard deviation of a mean. Okay, so what is one standard deviation of a mean? It is x bar minus s to x bar plus s. Now we have 30 measurement. I won't make you to calculate standard deviation and mean. Okay, it's given to us, it will be given to you. So your mean of this 30 measurement is 3.74. The standard deviation for this measurement is 2.2. Now, can you calculate this interval? So I want you to calculate this one standard deviation of a mean. So what will be this interval? What do we do next? You substitute x bar and s, okay? X bar is given to you and s is given to you. So let's substitute. X bar is 3.74 minus s, which is 2.20. Sorry, not the parenthesis, comma. X bar is 3.74 plus 2.2. Now, who can help me here? 3.74 minus 2.2. What is that equals to? 1.5. 1.5. 4. Okay. So 1.542. And what is this equals to? 5.94. Okay. So this is an interval. Okay. So the interval is starting from 1.54 to 5.94. Now we count the number of measurement, okay, out of this 30 measurement in this interval. Now how many measurements can we find in this interval here? Let's count. Does 1.97 belongs to the interval? Yes, right? So 1.97, 1.74. So we are counting every measurement that belongs to this interval, okay? So that's just in between. Yes, in between 1.54 and 5.94. So we are counting every measurement in between these two numbers. Okay, 1.74, 2.75, 3.77, 5.36, 3. Okay, this C is by error. Okay, so let me 3.81, 4.02, 9. Okay, not 9. 3.20, not 8. 1.71, 2.47, 4.25, 5.63, 4.44, 5.21, 1.93, 5.15, 4.55, 2.02, 3.37, 2.06, 1.65, 3.65, 3.16. Okay, we are counting every measurement which is in between 1.54 and 5.94. Now how many measurements do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Is that correct? So we have 23 measurements, okay, within one standard deviation of a mean. Now what percentage of measurement is this? So out of 30, 23 is within one standard deviation. Now can we convert this into percentage? What percentage of measurement is within one standard deviation? Okay, how do we find that? You divide 23 by the total, which is 30 multiplied by 100, right? And you said 77%. Okay, so 77% of percentage of the measurement is in between 1.54 and 5.94. Okay, that's what we can tell here. Okay, but what our Chebyshev's rule tells us, it tells that very few measurement will fall within one standard deviation. But this is not very few. We have like more than 50% measurement within one standard deviation. Okay. Now let's go to the second rule. Okay, does anyone have any question in finding this interval and finding the number of measurement? You will have a very similar question, okay, on your exam. Okay, now the second rule of Chebyshev rule is at least 3/4 of the measurements will fall within 2 standard deviation of the mean. Now let's find 2 standard deviation of the mean and let's count the number of measurement. Okay, now let's find 2 standard deviation of a mean. So what does it mean by finding 2 standard deviation of a mean? It is you are finding an interval x bar minus 2s. Okay, we are looking for 2 standard deviation. So x bar minus 2s to x bar plus 2s. Now let's substitute. X bar is 3.74 minus 2 times 2.20. X bar is 3.74 plus 2 times 2.20. So this is 3.74 minus 4.4. 3.74 plus 4.4. And what is this 3.74 minus 4.4? That is negative 66. Okay. 3.74 plus 4.4 is 1114. Okay, so we have this interval, okay, and this is our 2 standard deviation of a mean. Now how many measurement can we find within this interval? 28. Now, can we say that all this green measurement is in 2 standard deviation? It belongs, right? So we are looking for the measurement which is greater than negative 0.66 and less than 8.14. So we already have 23 measurement. Okay. So this measurement belongs to the interval. This also 1.15, 6.06. 7.6. So we have 23, 24, 25, 26, 27, 28. So we have 28 measurement that belongs to or that is within 2 standard deviation of a mean. Now what percentage is this? 93. So 28 divided by 30 times 100%. So 93% of the measurement. 93% of measurement is within 2 standard deviation. Now, similarly, I want you to find the 3 standard deviation and count the number of measurement in 3 standard deviation. Now, in the similar way, can you find the 3 standard deviation of a mean? So this. So what will be the interval for 3 standard deviation of a mean? It is x bar minus 3s to x bar plus 3s. This is 3 standard deviation of mean. Okay, we are using x bar, so this is of mean. Okay, now let's substitute. So x bar is 3.74 minus 3 times 2.20. X bar is 3.74 plus 3 times 2.20. So 3.74 minus 6.6. 3.74 plus 6.6. Does anyone have final interval here?
The
Negative.
part is negative 2.86.
Okay.
And then 10.34.
3, 4. Now we count the number of measurement. Okay, we count measurement in between negative 2.86 and 10.34. 28 is already included there. Now, do we have more measurement here?
Yes.
How many more do we have? 2 more. So it means, okay, so let me go back here. So this belongs to the interval. This also belongs. So it means all 30 measurements. Okay, out of 30 measurement is within 3 standard deviation, and it means what percentage? 100%, right? So 100% of measurement is in between our 3 standard deviation. Okay, so our every measurement is in between negative 2.86 and positive 10.34. Okay, any question in calculating these intervals and counting the number of measurement? Okay, now let's go back to our rule. So what it tells here, according to Chebyshev's rule, so within 2 standard deviation, we can find 3/4 of the measurement. What is 3/4 of the measurement? What percentage is that? 75, right? So, and what did we find in our example? Did we find 75% of measurement within 2 standard deviation? We find more than that, right? We find 93%. Okay, now the next year, at least 8/9 of the measurement will fall within 2 standard deviation. Okay, should be 3 standard, not the, okay, let's correct here. So this is not 2, within 3 standard deviation, okay? So at least 8/9 of the measurement will fall within 3 standard deviation of the mean. And what percentage is 8/9?
89%.
89, so 89% of the measurement will be within 3 standard deviation. But for in our example, we had like 100% of measurement, okay? So here we found 100% of the measurement is within 3 standard deviation, okay? And this is how we write in general, okay? So this is the general way to represent this ABC rule. Now, you don't need to memorize this rule. It will be given to you as your formula sheet. Excuse me. So here, the type of question you will be asked is that you will be given a data set, okay? And you will be asked to calculate 3/4 of the measurement, okay? So finding 3/4 means you are finding an interval 2 standard deviation of a mean, and you are counting the measurement, okay? So this is about the Chebyshev's rule, and we use this rule for any type of data set. Whether it is a symmetric or asymmetric, we can use this rule. But if our data set is symmetric, there is a separate rule, empirical rule, okay? So if our data set is symmetric means if the mean and median of our data set is equal, we call it symmetric. Symmetric data set has a bell-shaped histogram, okay? We also call it mound-shaped, okay? Now, if that is the case, if our data set is symmetric, okay, get rid of this line, okay? So it was supposed to be at the rule 1. So we use the empirical rule, and according to empirical rule, approximately 68% of measurement will be within 1 standard deviation of the mean. Okay, if we have a symmetric data set, if we have a data set with a mean and median equals to each other, almost 68% of the measurement is within 1 standard deviation. Okay, approximately 95% of the measurement will be within 2 standard deviation of the mean. Okay, and approximately 99.7% of the measurement will fall within 3 standard deviation of the mean if our data set is symmetric. Now, what can you say about this data set? Is the example is a symmetric? Do you think is it close to symmetric? Okay. Now see, like, so within 1 standard deviation, we had 77% of the measurement, okay, which is greater than 68. Within 2 standard deviation, we had 93%, okay, which is close to 95 here. And within 3 standard, we had 99.7, which is 100. Okay, so this data set is symmetric. Okay? We can call it symmetric, okay? So if you have a symmetric data set, you're going to use this rule, okay? 68%. Now here, let me just graph this here. So we are talking about symmetric data set. Symmetric data set means we are talking about the histogram that looks like a bell shape. Okay, so this is our symmetric data set. Okay, this is the histogram here. Now we have our mean at this center. Okay, so this is our mean, this is x bar. Okay, now let's construct an interval with one standard deviation. So one standard deviation, so let's say this is x bar plus s and this is x bar minus s. So this part is our one standard deviation. And what percentage of the measurement do we find in this region? So this region, okay, or this interval is our one standard deviation of a mean. And what is the percentage of the measurement we find in this region? 68. So this region has 68% of the measurement. Okay, now to standard deviation, so you go 2s, okay, from mean. So this is your mean, so this is x bar plus 2s. Okay, let's say this is x bar minus 2s. So from here to here, this is our two standard deviation. Okay, so this is our two standard deviation. We are talking about empirical, we are talking about symmetric data set. And according to empirical rule, what percentage of the measurement is this region? 95. Okay, so this is 95%. Now three standard deviation, so let's say this is x bar plus 3s and this is x bar minus 3s. So from here to here, so okay, okay, this region, so this is three standard deviation. And what percentage of the measurement do we find within three standard deviation? We find 99.7% of the measurement. Now what happens to the remaining measurement? So according to the empirical rule, in between three standard deviation we have 99.7%. We still have like 0.3% of measurement. And where do we find those measurements? So yeah, that we can say they are outliers, or there is a possibility that those remaining will be on the right side here or over here on the left side. Okay, and that is the one way. So if you have a measurement that does not belongs to, or that is not within three standard deviation, we call that outliers, and we'll talk about outliers in detail. Okay, so this is about empirical rule. And you should be able to construct this. Okay, these rules will be given to you. Okay, this will be given to you on your exam. You don't need to memorize, but you should be able to construct this diagram here. Okay, you should be able to find out this percentage. Okay, now let's go. Okay, let's take this example here. Okay, instead of that, let's do activities. Okay, we'll do example very similar to the one that we just did. Okay. So here we have a sample of 25 measurement. Yeah, you will be required to find the mean, standard deviation, variance. Okay, one more practice for finding the standard deviation and a variance. You can skip step here. Okay, in this case, when you are calculating standard deviation or variance, you can skip a step, but so you are required to find the standard deviation, find the mean.
11, 8, 9, 11, 10, 8,
And if you want to work in a group, yes, you can. Okay, you can work in a group and you can divide. Finding, so you can, one of you can find mean, and other you can find the standard deviation. So you are allowed to work in a group.
2 is 6, then you gotta divide it by 25. Okay. Divided by 25. Yeah. And that will equal that.
So you have 25 data set here. Compute mean, find S square, which is the variance, okay? Find standard deviation. And if you need help in finding mean, variance, standard deviation, please let me know, okay?
We're trying to find the
you will be asked to find the variance.
Oh.
You will be asked to find the standard deviation.
Yeah, so we gotta.
So you must learn how to find these values. The formula will be given to you, but you should know how to use it.
negative 114.
So that's